This is Professor Peld, and this is Algebra 2, Chapter 7, Section 2, Graphing Rational Functions. So a rational function is just a rational expression, an equation form where you have a p of x and a q of x. It's a fractional type function. Keep in mind, however, the q of x, the denominator function of the function, cannot be 0. The p and the x varies from book to book, but you can call them any letter you want. You can use f and g if you want. It doesn't really matter, just as long as they're different. So the overall function is two functions. They're both polynomials, top and bottom. So the key here is you cannot divide by 0. So that is going to limit the domain of possibilities, which is important for graphing because it can't exist there. So in this case, x minus 3 cannot be 0 because that would make the denominator 0. So a lot of students just say x can't be 0 every single time. That may be true sometimes, but what we're talking about is the entire denominator can't be 0, not the x value. That's two different things. So my domain is for all values of x except for 3. So it's least to greatest, negative infinity to 3, union 3 to infinity. So all real numbers except for 3. Okay, next one. X squared minus 9 cannot be 0. So if I add 9, x squared cannot be 9. So if I square root both sides, x cannot be plus or minus 3. Remember, it's an even root, so I have two possible values that I can't be, but I can be all other real values. So my domain, again, least to greatest, negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. Okay, so essentially there's two gaps in the domain. All right, next one. X squared plus 9 cannot be 0. So if I subtract 9, x squared cannot be negative 9. So if I square root, x cannot be plus or minus 3i. Well, wait a minute. 3i is imaginary. Domains and ranges have to do with real numbers. Since the only thing I can't be is an imaginary couple numbers, there are no restrictions to the real domain. So the domain here is all possible real numbers from negative infinity to infinity. Okay. All right. Lastly, there's a bunch of things I can't be here, right? So this cannot be 0. Therefore, x cannot be 0, x minus 2 cannot be 0, and x plus 5 cannot be 0. So x can't be 0, x can't be 2, and x can't be negative 5 when you solve each one of those terms. So my domain has three gaps here, going least to greatest. So negative infinity to negative 5, union negative 5 to 0, union 0 to 2, union 2 to infinity. Okay, again, least to greatest using parentheses, not brackets, because parentheses means you're not included. Brackets means you would be included. So if you use brackets, it's wrong because you cannot be any of those numbers and you can't get to infinity. Pause the video, try the student problems. Okay, so in the first case, x minus 5 cannot be 0. Therefore, x cannot be 5. So therefore, my domain is negative infinity to 5, union 5 to infinity. So I have one gap that's can't be filled in with the domain, essentially. Next one, x squared minus 25 is 0, cannot be 0. So x squared cannot be 25. So if I square root both sides, x cannot be plus or minus 5. So I have two gaps in my domain. So my domain is negative infinity to -5, union -5 to 5, union 5 to infinity. Again, remember, least to greatest how you write domain and range. And the last one, x squared plus 25 cannot be 0. So x squared cannot be -25. So if I square root both sides, which doesn't seem to be working right now, there we go. X cannot be plus or minus 5i. Okay, well that's imaginary, so that means there's no domain restrictions. So my domain is all real numbers. So negative infinity to infinity with no restrictions. Okay, so we have the arrow notation next, which will come up occasionally. What's important here is understanding asymptotes vertically. Okay, so what the arrow means is approaching. So this means x is approaching a from the positive side, x is approaching a from the negative side, x is approaching infinity, or x is approaching negative infinity, which you can really just say positive infinity there. So in the first example, as x approaches 0 from the negative side, right? That's what it's saying. This is the negative side of the graph. What's happening to the function? Well, the function is going up to positive infinity. I'm trying to write that in there very well, and I could not do it. Let me try that again. Positive infinity. So as x approaches 0 from the positive side, right? This is the positive side of the graph, right? This is my x-axis. What's happening to the function? It's going up to positive infinity. Okay. Next, as x approaches negative infinity is out here, right? So as x approaches negative infinity, which is my x-axis, what's happening to the function? Well, the function is getting closer and closer to 0, but never gets there. Okay. So next, as x approaches positive infinity, which is out here, what's happening to the function? Well, the function's approaching 0 again. So what you have here is a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. They're invisible lines the function is approaching or cannot cross depending on what it is, essentially. Okay. That is the end of part 1.